What's up, everyone? Today we are going to talk about pure functions. I've had this question quite a few times in interviews, and it's a pretty foundational topic, especially if the team that you might be joining is into functional programming. You might hear this a lot, you might get this question a lot, so it's good to know what it is, why it's useful, etc. And yeah, if you are unfamiliar with functional programming in general, then I recommend maybe studying up on that, as especially over the past, I'd say, like, I don't know, 5 to 7, 8 years, something like that. Over the past decade, it's definitely picked up in popularity in the JavaScript community, and so it's definitely worth your time. I actually might do some other videos on functional programming too, but for today we're going to do pure functions. And what is a pure function? Let's just dive right in. So I actually have no notes here. I'm just going to live code this stuff. Normally I make some notes in here so I can cheat a little bit, but we'll see how this goes. Okay, so first off, a pure function is deterministic, meaning that if I give it x, it will always return y. If I give it x and y, it'll always return a and b. Like given the same inputs, you can call this function a million times, and it's always going to give you the same outputs. And so let's look at what that means. Let's make a function here, and we're going to do the classic example of add. If you've ever seen a video on pure functions. All right, so this is a function that adds two things. It accepts x and y, and it's going to return x plus y, right? And if we call this like a million times with, x is 3 and y is 5, we're a million times we're going to get 8, because 3 plus 5 is always 8, right? Like, I think it's fair. I didn't do great at math in school, but I'm pretty sure it's always going to be 8. Someone out there right now is like, oh, well, I could probably prove it's 9. Okay, whatever. Doesn't matter. So this is deterministic. What is not deterministic? So what if we have a function like, what if we have this function here actually, but say inside it, for whatever reason, we say we're gonna call this some chaos. We're gonna say math.random. And then we're just gonna like tack on chaos. Well, this is gonna be a different number every time, right? Like, you're gonna give me x and y, and I guarantee you, unless like the stars align, by the second function call of add, even with 3 and 5, you are not going to get the same result, right? Let's see, I'm trying to think if there's a better example here, but hopefully that at least gives you the gist of it. If there's something happening inside that, like if you have conditionals or anything that could affect the result of x and y always being equal to x plus y here, then your function is not deterministic, and therefore it is not pure, right? Next characteristic of pure functions is that they have no side effects, and what that means is the function doesn't know anything about the outside world. The function, it knows about itself, and it's super. It's kind of a hermit. Like, it's all about itself. It doesn't know anything else about the outside world. It just it only cares about, like this function here, only cares about the x and y you give it, taking care of them, and returning them to you added together. It doesn't know anything else, and so this function actually has no side effects. However, if a function reaches outside of itself, it's aware of something outside of itself. It therefore produces side effects. Let's look at an example. So what if we have like I'm using var, get over it. What if we have var values, and it's like an array here, and I don't know why you would have this, but like who knows? Like, and then we say this function subtract, right? And then we take in x and y, and then we say values dot push x. I don't know why you would do this, but whatever. And then we return to you x minus y. right? This function has a side effect because it's mutating this global state here. It's reaching outside of itself, outside of these two lines, and it's mutating something that is outside of itself. So this is a side effect. If you wanted to rewrite this as pure, it would you wouldn't. I mean, you can't reach out and like modify this state, or it's therefore my gosh, my words. It's therefore not pure because it's reaching outside itself. Now, let's see. Another way to kind of test whether or not you have side effects and also kind of whether or not your function is pure is if your function is pure, it will be what's called referentially transparent. And what this means, this is just some big word for let's take our add function and we'll say, I don't know, const results equals add 2 and 2, right? So result we know is 4, right? Like 2 plus 2 is 4. Referentially transparent means if I have this const result and I'm using it throughout my app and all this good stuff, anywhere where I'm using add 2 comma 2, anywhere where I'm calling add with those two arguments, I could delete that and replace it simply with 4. Like I could say, instead of const result equals add 2 and 2, I could just say 4. And it's the same thing. Like the value is the same as the return value of the function given, x, y parameters. That is referential transparency. So no matter where I'm using this, I could say, const another result equals result plus 2, whatever that is, and we could say another one, whatever. Doesn't matter. The point is, I'm using result here in the app. Anywhere where I'm using that, like right now, it's add 2 and 2. I could say just 4, and the program's going to run the same. It would not be referentially transparent if I couldn't do that, obviously, but also just like, what if this add function also, for whatever reason, like goes out and like logs something to a database or logs something to it's like an error reporting service or an analytics service or something. That means that like that's happening when you call this function, not right? Like if I have I don't know, we're just gonna say cool analytics service as if there is one. That report add function was called. No one would ever do this, but hopefully you get this. Like if now this is calling this, first off, this now has a side effect, so we know this is not pure now. But also to prove the referential transparency, like kind of drive that point home. This, if I change this to 4 now, that's not the same. It's changing the meaning of the program. The program now, where it was calling this function and sending this stuff over to the analytics service, now it's not doing that anymore. And we've changed the meaning of the program by not calling that function now. Versus now, if I go back to this, I'm not changing the meaning of anything if I just change this to 4, right? Like we're good. So that's referential transparency. The last point to cover just quickly is there's a few benefits to pure functions. Not sharing state, keeping things kind of smaller scope and where they don't reach outside themselves. These are great benefits. But one really good benefit of pure functions is they're extremely testable. Like it's so easy to write a test for a pure function because again, you call it with x and y and it's always going to give you y and z or always going to give you z, whatever it might be. So when you're thinking about like how to write your functions, how to design your program, think in terms of pure functions where possible. Sometimes you can't avoid side effects, like especially on the web. Sometimes things are inherently going to be a side effect. Like you can't just not write a side effect at all in a web application. But where possible, shoot for these because they're extremely testable. And so If you don't know much about writing tests, I don't have any videos on writing tests yet, but Kinsey Dodds is like the testing guru for JavaScript. So go check out his course, testingjavascript.com, and he talks all about this. I think that's going to do it for today. If you have questions or something didn't quite click, I'm happy to make a round 2 of this video. Just let me know, and have a great week.